Meow. Hmm. Meow. I'm having trouble with YouTube at the moment. Where the player keeps refreshing itself infinitely. Uh-oh. Oops. I don't know. I'm having issues with YouTube at the moment. Let's see. See. Oops. Ah. Give me a moment. Wow. Commanding AK Manning the consultant and Barton. Thank you. Whoa, whoa, whoa. Let's turn this one off. Let's close this. Yeah, that was really weird. YouTube was, it was like infinitely refreshing the video player. I also have too much stuff playing right now, so let's give this a break. Go here, go here. Okay. Let's get started. Let's get started. What a waste of the beginning. Ah, jump in now. I saw something just yesterday about AI that can keylog through audio from the sound of keyboard presses. And then there's a lot of people saying that this is old tech. You don't need AI for that. But I find it interesting because, yeah, because I guess, different words have different sounds when they're typed on a keyboard, and maybe that sounds really obvious, but I don't know. I don't know. I guess if maybe that's a reason to keep my errors higher, like my accuracy down. Oh, that was really close. That was really tight and close. Okay, no, not too much a type racer today. How's everybody doing? Hope people behave a bit today. I hope. Honestly, I was feeling a little bit anxious to start because I'm a weak kitty. I'm a weak kitty. I don't really wanna, what is it called? I don't know. There's like, yeah, I don't want to be moderated. Manning nightmare. How have you been? What's up? How's work? How's life? So I came back to this one because I redid it last night, and I want to share my work. So some people said that I was over engineering my solution, and I didn't really understand that, but I think that could be true. So my solution yesterday, because I couldn't understand this syntax. I guess I didn't learn math well enough. Oh, congratulations. I hope it goes well. I hope you like your new team members. Also commanding Sirpalha. How are you? Uh-oh. Oh, that's great. That's great news if you have like more time or a bit of a break. So I decided to use factorial because I looked on Wikipedia and n choose k is like it's a what is it, combinatrix? It's like a factorial problem. So I thought it would be easier for me to do factorial than it would be for me to try to figure out what this was saying, because I didn't understand this part. But it was explained to me a little bit. Oh no, Baratam, I didn't mean it in a bad way. I was just saying it in a like, you know, every time I write something now, I try to think, oh, what's another way I could write this? So last night before sleep, I couldn't sleep. So I tried rewriting it, and I was really pleased with this solution. It's a little bit more elegant, maybe. I don't know, actually. To be honest with you, I still like my first solution because it's very clear what's happening. You have the factorial equation, and then n choose k uses two numbers and then combines them with factorial. Is fine, whatever. But I can admit that this version using a range is smaller. Thank you. There's no need to moderate. I'm gonna say this again, Oni-chan. Hope you have a good day as well, but yeah, I don't really need mods. Okay. Let's see. So, um, one thing I'm not really sure of is if there's like a cleaner way to handle variables that I'm going to use that I haven't used before. I feel like maybe I'm doing something wrong with this setup, but it works. I don't know. Like, I don't know what's, yeah. I don't really know what I'm doing, is all. So I went with combination is equals 1, because I know I'm gonna need to do multiplication. And then, because we have the, what is it called? Like the rule that n is greater than k, which is greater than 0, we know that both n and k have to be greater than 0, and n has to be greater than k. And if we're going to subtract from n and k, so n minus 1, n minus 2, etc., and k minus 1, k minus 2, etc., our limitation is k. Because we can't let k become 0. Maybe this is obvious too, but the first time I thought about it, I got stun locked because I thought I had to use n, but I think k makes more sense. And then, yeah, set that as a condition. If n is greater than k and k is greater than 0, then you can, well, first you multiply n over k times 1, and then you subtract 1 of each, and do it again. You keep doing it again and again and again, until k is 1, or whatever. Anyway, it works. It works. I tried it last night. So, I'm a little bit tired. I'm a bit sleepy. And anxious, man. Oh, I gotta calm down a little bit. Caesar's JV. I don't know how to read this. Cryptography is the art and science of hiding the meaning of information in a way that only some people can see it. In this lesson, we will introduce one of the simplest cryptographic methods, the Caesar cipher, also known as a shift cipher, and you will write a program to break it. You will design every aspect of your solution, unlike lesson 15A, which we broke into subparts. Well, I didn't do 15A because you told me that they could be completed in any order. The Caesar cipher works by replacing each letter of the alphabet by another. To be precise, whenever you want to encode some text, you need to pick a shift value S, which is a number between 0 and 25. Then you replace each letter in the text with the letter, which is S positions later in the alphabet, circling around to the start after you reach Z at the end of the alphabet. Example, suppose we want to encode the secret message, join me at 8 by the zoo, using the shift value S equals 2. The encryption rule says each letter is replaced by one which occurs 2 positions later in the alphabet. For example, since the alphabet is A, B, C, D, E, F, G, H, I, J, K, L, the first letter J will be replaced by the letter L. Continuing, the O is replaced by Q, I is replaced by K, etc. To encode the letter Y, we have to circle back to the start. After Y comes Z, then A, so Y is replaced by A. Likewise, Z is replaced by B. So the encoded version of our secret message is L, Q, K, P, etc. If some spy saw this message, it would not be obvious to them what the message was about. Short answer exercise, SpyCoder. What is the result of encrypting SpyCoder with the shift value 5? Use uppercase. You can write a program in the console to compute this if you like. It might be useful later. Let's do it in mine. We could do it in here. I gotta learn how to use, what is it? Multiplexing. I need to learn how to use like more than one. Actually, will that be too off topic? Would that be too off topic? I think this does something. I don't know how to switch between. Because I'm in here. Let's see. How to switch between terminal windows. I don't know. Terminal. I don't really know what any of this does actually. This is okay, that goes back. Terminal panes. Wait, terminal panes in Mac OS. Terminal. Apple's terminal application only supports horizontal splitting with each press of Command D and Shift Command D to undo. Right. Shift Command D. Command D. Okay. But how to switch? Let's see this. Move between them. Get iTerm. It can do so much more, or use Tmux. I've seen people talk about Tmux a lot. I don't want to use it just yet. No vertical split. No apparent keyboard shortcuts to jump between the split panes other than Command T to change split pane into tab. Is that true? Wait, Command D, Command T. Ah. Oops, I didn't mean to do that. Shift Command D. Shift Command T. Okay, well, that doesn't. I'm in trouble. I'm really in trouble. I need to look for a pop-up blocker that prevents those Google sign-in pop-ups. Universally. I know that I can split the terminal into multiple panes. I'm facing is all existing panes are synced. If I type in one pane, the same text appears in all other panes. Oh, is that true? Oh, that is true. It allows you to keep a certain part of the shell buffer displayed while continuing to enter commands, so only the lowest split allows keyboard input. To position the view. Okay, so that's not really what I need. Um, 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 how to use Tmux and why it's better than Screen. "15 years and 6 months ago. Modified 2 years and 2 months ago. In Screen, you can send commands to an attached session via Screen as automate me x stuff command echo blah blah blah. You can't in Tmux. But this is old news, right? It's 2016. Pretty useful for testing. That's why I wanted to use Screen and not Tmux, but I don't really know. I don't think this does what I wanted to do either. Status bar. Any command you can run in Tmux can be run from a shell with Tmux command. More accurate automatic window renaming. Yeah. Nicer session handling. More actively developed. Oh, this is in 2011. The new Screen is almost 25 years old. Wait, in 2011. Uh-oh. Meow, meow, meow. Okay, whatever. I don't feel like reading this right now. This was a little bit off topic. I just can't decide if I wanna if we're the bad guys. Auto decryption. You just have to forgive me. I'm a little slow this morning. Maybe always, but also this morning. Let's see. We're gonna take some input. Unencrypted. And then for character in unencrypted, we want to make a new a new string and add to the string equals, let's see, there's char and there's ordinal. I think we need the ordinal of unencrypted. Uh, let me think. Meow, meow, meow. It's just gonna give me an error. String indices must be integers, not string. How do I do this again? It's a method. I need index. Yeah, index. That's what I need. What if I do both? Should I get a range? No, I just get the first character. That's fine. I only need one character at a time. Let me think about this. We want to. This is why I shouldn't write code right away, right? Let's go back. Given the string, iterate through each character, each half letter character. And then meow, meow, meow. And then we want to check each character's ordinal value let's see. B W X Y Z. Wait, is that 4 or is that 5? B. We don't really need to evaluate it. Check. If character is between A through U, right? U, B, W, X, Y, Z. Add 5. This is not the right way to write this. It's okay. Or think it through. Meow, meow, meow. Let's see. What's another way of writing this? I know they mentioned 0.25. A range of 0 to 25. But I don't know if that really helps. Let me think. Meow, meow, meow. The issue I'm having mentally right now is that although the alphabet maps to the indices 0 to 25, that is not the same thing as the like ordinal value of the letter. But that shouldn't matter. It matters a little bit, but it doesn't matter. It doesn't really matter because of the position, right? Um. Let's see. I don't know how to write this in English, let alone writing it in code. Okay. Hmm. Hum. I guess it's. This is 25, and this is 24, and this is 23. This is 22, and this is 21. I feel like this is a bad way of writing this, though. Um. I don't know how else to write it. But then how much? Um. Hmm. Ah. What do I want to do? So if I'm V, 26 minus 21 is 4. And then what I need is that difference. I need to recall that difference. Um, uh, add. I didn't even need to add. I just did. New index. But we're not gonna use indexes. Okay, let's see. Word A. Word C. I'm glad this is only uppercase letters. It makes it a little bit easier. Word. The other thing is we did a problem like this, and I don't think I reviewed the answer enough, so that's why I'm probably approaching this problem kind of weirdly, like with too many steps. But it's okay. Let's give it a try. Just give it a try. Hmm. Um, um, um. Unencrypted dot index at the character gives us oops, of a string. I think I have this wrong. I do. Let's go back. Let's go back. Let's go back. What do I want to do? I need to know each letter. Is it a letter? if Lord car is between 65 and 85. Greater than or 65 is less than or equal to the ordinal to character or some do we want to include 85? 86, 87, 88, 89, 90. Yeah. Then we want to we want to we want to take that number, add 5, so ord char plus 5, and we want to replace it with a new character. And add it to encrypted. But I forgot how to append. So I just how do I append to a string? Oh, you can't append to a string because it's immutable. We can make it a list. And then change it to a string later. But we don't have to do that. We could. Sorry, my brain is so small. Wait, my brain is so small. Okay, we take it. What do we want to do? Add. I need string methods again. I forgot them. Read a new string object from given object. Meow, meow, meow. Oh, it's space. Interesting. What would you replace? Return a copy with all occurrences of current of substring old replaced by new. Return a copy? What does that look like? I don't think we could do that though, or can we? Let me think. Well, we could a character with this. The only thing is it replaces all. So it wouldn't work because it's gonna like actually it would work. Wait a minute. It would work because strings are immutable. Wait a minute. Oh, this is actually this might work. I'm really sorry. I'm really sorry. I'm so sorry. Place care. I'm so sorry. I don't know. This is so ugly. I don't know why I'm apologizing to you. I should be apologizing to my mom. She would be so ashamed. This is really terrible code. Okay, it's fine. And then no, but this doesn't work. Wait, this is gonna keep replacing the whole string every time. Man. Okay, let's go back to our old idea. Let's go back to the old idea where we don't use a string. We just I can't think of how to do this with a string. We're gonna use a list. Yeah, we're gonna use a list. And then we're gonna turn the list into a string later. I forgot how to do this though. We need this to be Meow. Oh man, I can't believe this. I can't believe this is taking me an hour to do. I haven't even touched the actual problem yet. It's fine. Can I do this? Is this illegal? I need to do math. My brain won't let me. No, I blame the brain. Blame the brain. Instead of this thing, we're going to take the ordinal of the character. Let's say it's 86. Right. 90 minus 86 is 4. And then once we have 4, what do I want to do? 5 minus. I think this should be a different thing, a different step. I'm gonna call this I don't know what to call this. This is bad. This looks like nonsense. Ha ha ha. Difference equals some integer, like 4. And then we need the difference between, we did 5 minus difference. And we're gonna add that to if that's 65. Does that actually work though? Is that what we actually want? I'm very confused. Oh, yeah, I'm really confused. Let's pretend that A is 0. Let's not pretend that A is 0. Let's just acknowledge that A is 65. It's greater than. So we have 86 as an example. If it's 86, right? So we get 90 minus 86 is 4. 5 minus 4 is 1. 1 plus this is 66. So we get the letter B, but we need to have it also be for A. That's why my brain is hemorrhaging right now. Ha 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 ha. So V W X Y Z A. We need V to give us A. V is 86. 86 meow meow meow. Ord C minus ord B still 4. What if we just make it 4? Four minus the difference plus ordinal A encrypted. This is horrendous. Why do I do this? Why do I write like this? No, no, it's like, but I understand it. You don't understand it, but I understand it. I don't understand it. Um, I'm in trouble. I'm in so much trouble. I'm sorry. I'm sorry. Oh, join. I forgot the method. Um, 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 um. Oops, I didn't mean to do that. Please send me out. Spy coder. Okay, it gives us words. Is it correct now? Okay, A, B, C, D, E, F, G, H, I, J, K, L, M, P, Q. Oh, it's right here. S. 1, 2, 3, 4, 5. P. 1, 2, 3, 4, 5 is you. Y. 1, 2, 3, 4, 5 is D. Oh my god. C. 1, 2, 3, 4, 5 is H. T. 1, 2, 3, 4, 5 is Y. Wait, no, I did that wrong. It's O. 1, 2, 3, 4, 5 is T. D. 1, 2, 3, 4, 5 is I. E. 1, 2, 3, 4, 5 is J. R. 1, 2, 3, 4, 5. It works. X, U, D, H, T, I, J, W. Yeah! God, that took me so long. That took me so long. Okay. Now, is it clean? No. Is it understandable very easily? No. But does it work? So far, yes. Okay. Decoding. Once your friend gets the message, if they know the secret shift value S, then it's easy for them to decipher the message. Each letter is replaced by the one appearing S places earlier in the alphabet. For example, they would look at L, step back 2 positions in the alphabet and find J, which they now know is the first letter of your secret message. Again, they have to treat the alphabet as cyclic, assuming that Z comes before. But you know what? I didn't use a shift value. Maybe I should figure out how to do that. That seems like something useful. Because it would make this more... It would make the code more reusable. Oops. Oh, they called it S. I guess we could call it S. And then replace this with S. And then replace this with S -1. And it should still work. I think it does. Meow. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. T. And W. 1, 2, 3, 4, 5. Okay, that's better. If the encrypted message is HUD and the shift value is S equals 6, or it was the original message, use uppercase. Okay, so this is for spy coder. Now we have spy decoder. And I'm going to not reinvent the wheel. I'm just gonna steal the wheel, or steal the patent for the wheel. And fix it. Also, I will comment this out for now because I don't need it. And then man. Let's see. We have something that's encrypted, and then we want to unencrypt. We could still keep an S, but we're going to use a shift value of 6. But does our logic need to change? Kind of. Since we're going in the other direction. Actually, I just realized if we change our shift value, the window also changes. How can I write this to include that? Ending at the character is between the beginning of the alphabet and the end of the alphabet. Actually, I think this would be better if I was consistent. So it's if it's, then it's chord C, which is 90 minus S. This is chord C. Oops. Ah. Okay, sorry, my brain cells are kind of dwindling. I forgot I was streaming for a bit there. I need to go the opposite direction now. We get an encrypted input and we want to get the unencrypted message. We're going to shift 6, but in the opposite direction. So, we want to know if the character is between, let's see, we're going to have ord A on this side. Order Z with the shift value. The S is gonna be on here, but it's a. Let me think about this. Um, would be plus, right? S. Let's think about this. If our letter is C, we need to go back 6. 1, 2, 3, 4, 5, 6. And the only ones we're gonna have to go back to the end for are gonna be the ones in the range from A to S. So, wait, let me think about this one more time. For 5, we start at 90, 85. For 65, we want to go to 71. 65, 66, 67, 68, 69, 70, 71. 1, 2, 3, 4, 5, 6. So this is G. In other words, let me think a little bit more. Ninety, 89, 88, 87, 86. So 85 included. Oh yeah, that's right. Okay. 1, 2, 3, 4, 5, 6. Yes. So starting from G to the end of the alphabet, if the letter is in that group, then why did I do that? Then unencrypted is going to equal the ordinal of the character minus s at the character at that position. So here this would be, we said 71. 71 minus 6 is 65. So we should get A. Otherwise, if it's greater than, not 85, but if it's not greater than, if it's less than, let me think about this again. Right, because 85 was just the same thing as 85 is the same thing as ordinal z minus s. My brain really hurts thinking about this in this way. I have to go back and check if this even works. Where was I? Meow, meow, meow. If it's in here, it's less than. If it's FEDCBA. Oh, Then, so let's say it's 65, and we want to go back 6. 65, 1, 2, 3, 4, 5, 6 is U. AC minus S C minus I gotta rewrite all of this. It's gonna be adding to unencrypted. Meow, meow, meow. Is it a difference that I'm looking for? A plus S was Z. Let's use B. If 66 is less than 71, how do we go back 6 times? Well, we need 6 minus. Oh, my brain hurts so much. Need ah. Go back once here and then 5 more times. Meow meow meow. I did it the other way, why can't I do it this way? The difference between the end and the character. Okay. Oops. Have word of character minus word A. Right? So 66 minus 65 is 1. And we're gonna do S minus 1. We're gonna move original Z minus minus 1. So that's 90. And let's say it's 6 for S. The shift is 6. 6 minus 1 is 5. 90 minus 5 is 85. 1, 2, 5. And we want to print the character at the position. Sorry, I'm being really quiet. I think this actually works. I'm not really sure though. Let's test it. We gotta test it. Let's see. Auto decryption. Let's see. In line 20, indentation error. Oh, how did I mess this up? Okay. HUD. Oh, this is a problem. Encrypted input HUD. Unencrypted is an empty list. For character in encrypted. That's probably the error. Let's see. Okay. BOU. Now let's see if that's correct. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Wait. D. 1, 2, 3, 4, 5, 6. We should be getting X, or we get a U. Okay, we're close. Something is wrong with my math. Let's try with the D. 65, 66, 7, 68. If 68 is less than 65 plus S, which is 71, so we take 68 minus 65, which gives us 3. Wait, why did I forget to use difference? I'm missing difference in here. Okay. Oops. I don't want to look at that one. I don't want to look at that one. So, we have a difference, which is 3. And we want to go from Z, not minus 1, minus difference. F minus 3 is 3. Oh, wait a minute. There was a reason for a 1. Because we don't want to go back 3. We want to go back 2. 1, 2. S minus minus 1 minus difference? Does that do the same thing? Let's think about it. Difference between B, 67, and ordinal A, 65, is 1. Ordinal Z minus six minus 1 5. My brain hurts. Why did I go with B? I meant D. Shit. I can't keep up with this. 6, 7, 8. 68. Okay, 68 minus 65 is 3. 90 minus 6 minus 1 is 5 minus 3 is 2. 90 minus 2 is 89, 88. Should give us X. Uh-oh. Wait a minute. Did I DC? Odyssey is so weird. You're just kicking me off. You're kicking me off to stream for no reason. HUD. Box. Yay! Okay. Well. Before I read this, I'll take a look at chat a little bit. I have a headache. Good evening, Phoenix. Hello, OK Race K. Hi, to consult it. Don't think you DC'd. Thank you. I thought of it in like 10 minutes. It's not going to be good. Think about it. I need to think about it for a while. Okay, maybe I shouldn't read backwards because it doesn't make sense. How far should I go back? Okay, I hope Baratum is having a good day. Oh, there's a lot of chat. Oh, there's a lot of chat. T-Max, turn me out now. Oh, good day, Brad. Mac OS just like me. Screen doesn't fit your use case, says Luminous. Luminous, you're wrong! I have another use case. I've used screen for something else before. So Luminous, there's this thing called... Sorry, this is gonna take me a while to get through all these messages. There's something called Vim Slime. Is it this one? Yes, yes. So I like Vim Slime because you can oh, I guess you could use the T-Max with it. I only used it with screen. Well, yeah, because it's a default. Anyway, what I like is like you can like type code in one window and then have a REPL in another window. Blah blah. Wish I could afford a Mac. Stick with Linux. I think Linux is great. I want to, honestly, I wish I could switch completely to Linux, but that's a whole other thing. Meow, meow, meow. You want a shift parameter in case you want to do rotate, but it's based on X value. Just reminding the spy doc mentioned that. Thank you, Luminous. But yeah. Hi, Slime. Long time no see. Hi, White Knight. Long time no see. This reminds me of when I started, when we had to choose, we had to do those in C or C++. Hi, Splendissimo. This is how I would implement it for lowercase. I don't know if this works. I don't know either. Oh, that's good though. Oh, I didn't think of using modulo for 26. And I don't know, I don't have the brain cells to see if that works. But it probably does. The channel, don't want to spoil it, but I want to give base knowledge, damn. Yeah. I will admit, for those of you who are new here, it's probably going to be really frustrating to watch me because I'm a beginner. But it's part of the process. X is whatever lowercase character only works with lowercase. You can't write your thoughts out, draw it. Oh, yeah, that's true. Hi, side character. Hi, Griffin. Long time no see. Challenge Doc doesn't mention anything about the table. She's aware of the table. How the table have coded. Hi, Corey. Long time no see. Too many steps is fine. You can eventually reduce it and optimize. So thank you. Can you move the terminal so we can see the problem? Sorry. I'll remember that for next time. I hope Baratham is okay. Meow, meow, meow. Hi, Rizako. Mom would be impressed. I don't think so. My mom will only be impressed when I move out. Aren't cats supposed to love strings? That's a good one. That's a really good joke. I like it. Meow, meow, meow. It's basically organized nonsense that only sometimes works. Hi, Corey Daniels. Alphanumeric means letters and numbers. I don't know what I said. Yes, it was a Caesar run. I wonder why people who made ASCII separate the lower and upper by punctuation. Ha ha ha. Sorry, there's a lot of chat. I missed so much chat. Okay, I don't feel like reading anymore. Anyway, my brain. I just need a little break. Quite a bit of backseating, but I couldn't see it. I think it's natural. Good evening, Phoenix. I sleep. I AK. Having my compiler course midterms, I think it went well. Congratulations! Yay! Congrats. I'm learning Rishab Sharma. Still learning. Meow. Meow, meow, meow. Do you get a break? Do you get a break after the semester is over? Or do you go right back to it? Speaking of breaks. Now this part is right up my alley. Working for the bad guys. You've been hired by a spy. My mom is gonna be so happy. She's gonna be like, wow, the kitty cat finally got a job. Even if it's a spy, she would be happy, I'm pretty sure. To help decipher a message encrypted using a shift cipher. Sadly, the spy does not know the value of S. You will use statistics to write a program that has a good chance to automatically find the right value of S. Our method will be to use letter frequency analysis. In English, some letters are very common, like E, that's true, and some are very rare, like J. Here's a table of frequencies based on counting the occurrences in a large body of text. Okay. Z is like super rare. Why the heck is E so popular? Hey, is up there. T is also really popular. Oh, okay. After finals, a couple months more. Oh, okay. I don't even know. I don't have a good sense of like what time of year it is. For example, the frequency of L is 0.0402 or 4.2%, which means in average English text, 4.02% of the letters are L. Call the goodness of a letter its value in the chart above. Then, for our statistical method, define goodness of a sentence to equal the sum of goodness of each of its letters. For example, goodness of the string good is goodness good equals 0.0202 plus 0.0751 plus 0.0751 plus 0.0425. Now, the idea behind frequency analysis is that strings with higher goodness are more likely to represent English text. For example, if the spy sees the encoded message JRRG, this might either represent the original text good with a shift S equals 3 or IQQF with a shift of S equals 1. But the goodness of IQQF is 0.0938. Since 0.938 is less than 0.2129, your program should conclude that good is more likely to be the correct message. Oh, this sounds really cool. Wait, this sounds really cool and hard. ASCII, adding stuff between upper and lower case is so that when written in binary, you can ignore case and just read the last 5 bits. Measuring strings by goodness is not perfect. Say the secret message was jazz and the secret shift value was S equals 10. So the encoded text was TKJJ. When you put TKJJ to your solver, it will try S equals 10, giving jazz as a possibility with goodness 0.08 or 6, but the best is S equals 5, giving Offie with a goodness of 0.3514 as the program's best guess for the secret message. Your program should go ahead and put the non-English word Offie. Frequency analysis of this type works better if the secret message is longer. Okay, I'm not doing this today, but take a look at the prompt. Write a program which does the following. First, it should read one line of input, which is the encoded message, and will consist of capital letters and spaces. Your program must try decoding the message with all 26 possible values of Shift S. Out of these 26 possible original messages, print the one which has the highest goodness. Oh, I like this. For your convenience, we'll predefine the variable letter goodness for you. A list of length 26, which equals the values in the frequency table above. Okay. Well, yeah, we'll do this tomorrow. Brute forcing. A very appealing solution in this case. Yeah, this one seems really fun, but I'm tired. And I've been streaming for almost 2 hours, which is my new limit. Do more tomorrow. Ah, no, don't tell me the secret. The solution, oh, someone said this already. The solution above is called a brute force solution. Since you tried all 26 possibilities, you could have even done this by hand if you needed to. Modern cryptographic protocols, on the other hand, are designed so that brute force solutions fail, even if you use very fast computers to try all possibilities. If you wanted to make this auto-decoding system more accurate, you could pay attention to other English statistics such as what letters are likely to occur in pairs next to each other, what letters are likely to start a word. This is also useful for more general substitution ciphers, where letters replace letters but not in a cyclic way. For such ciphers, brute force does not work since there are 26 times 25 or 26 factorial possible substitution ciphers, which equals approximately 4 times 10 to the 26, 400 septillion. I haven't completed the message, and I cannot send my friends encrypted messages because I don't have any friends, but it's okay. Good practice. Yeah, I think it was a good practice today. In cryptography, a substitution cipher is a method of encrypting that creates the ciphertext by replacing units of the plain text in a defined manner with the help of a key. The units may be single letters, pairs of letters, triplets of letters, mixtures of the above, and so forth. The receiver deciphers the text by performing the inverse substitution process to extract the original message. Substitution ciphers can be compared with transposition ciphers. In a transposition cipher, the units of the plain text are rearranged in a different and usually quite complex order, but the units themselves are left unchanged. By contrast, in a substitution cipher, the units of the plain text are retained in the same sequence, but the units themselves are altered. There are a number of different types. If the cipher operates on single letters, it's termed a simple substitution cipher. A cipher that operates on larger groups is termed polygraphic. Monoalphabetic cipher uses fixed substitution over the entire message, whereas polyalphabetic cipher uses a number of substitutions at different positions in the message, where a unit from the plain text is mapped to one of several possibilities in the ciphertext and vice versa. Okay. This will come in handy for writing the manifesto. Thank you guys for hanging out. I hope you have a really fun day. Aside from, oops, that's my alarm. Aside from practicing, there are some projects I've been, thinking about. I've been making a list. Yeah, the manifesto. I don't know what enigma is. I just know that I will continue this tomorrow. And, oops, I didn't mean to do that. That's fine. Yeah. Bye. Thank you. Bye. Her brain stopped working.